In this question, it asks you to calculate the number of perfect squares needed to calculate a number. Now, let's say n equals 5. So, and I create a list like that. The sort of the simplest way to do this is by adding 1 5 times, right? So if n equals 5, then the number of required perfect squares can be 1 5 times because 1 squared is 1, so I can say there, so I got 5. So that's the answer. If n is 10, then the minimum number amount of squares, perfect squares I need is 10. And to represent this, I can just simply say for I in range m plus 1, I, because you get the total number of fives. But here it wants the minimum number, you know, not just any perfect squares, but the minimum amount of squares. But let's say for the simple scenario, if we do this, then we are finished. We have the number of squares, but it's not the best or not the optimal amount of number of squares. And I do dp minus 1, I get the last value. In this case, if it's 5, then I need 5 ones. If it's 6, then I need 6 ones. Now, how do I find the optimal value? I iterate through, oh, sorry, I iterate through the n plus 1. So again, I'm iterating through all of these values, and I create a holding value, in this case, j equal 1. And I say, hey, my first value is 1, and we know that by adding several amount of ones, I'm able to calculate the minimum amount of squares. But what if I change this 1 to 2, or to 3, or to 4, or so on and so forth, to try other perfect numbers? So in this case, I'll present this by saying while j times j is less than or equal to I, and I in this case, I said is if we do our virtual list here again. So let's say I want to know, let's make it a bit bigger. So I want to know what's the perfect square for 6. Well, I started by 0. In this case, I know that it won't yield anything, but let's start with 1. So 1 times 1, is that less than I, which in my case, let's say if we're at 6, then I'll say yes. Then here is the equation that I need to know. It's a mathematical equation, I won't prove it. But basically, to find the perfect amount of square for any number, you do I minus j times j plus 1. And this is basically an equation. And if you memorize this equation, or if you go and search the internet for its proof, you would see this is what you need in order to calculate the perfect square. And then you iterate on the j. So then you try 1 times 1, 2 times 2, 3 times 3. Well, the higher the number, the less amount of squares that you need. Now, as you iterate through this, you want to actually compare it to the minimum of the current DP. Because remember, we created a list that contains all the minimum values or the simplest values. And if this equation returns a higher value, then you know that, hey, I already have a list that contains sort of this naive calculation of my values. Now let's click submit. And it's doing the calculation for us. And then we get the answer. It's not the fastest solution out there, but it's one of the simpler ones with dynamic programming. Thanks for watching.